I asked Brynhildur about what kind of group I would have, and the conclusion that we came to was I should give something that is very general. My background in geochemistry, so I will not bother you with any geochemistry, but I will just talk in very general terms on energy resources. So I will touch upon three topics mostly. One is the energy usage in the world at present, and then go down to more detail on geothermal energy, what it is and how it is used and what its importance is. And three, look specifically at geothermal resources in Iceland. This was Brynhildur's request. I want to have this just international. But so first, let's look then at the energy resources that we have. And what I have started to do a little bit with PowerPoint, if you only have diagrams and nothing but diagrams, and you look at it after 3 months, you don't know what the heck this is all about. So there is a fair amount of text that hopefully will put you online, and then you have all the diagrams and you understand. So it's like a presentation in the sense of being towards a book, if you like. But the types of energy that we can use today is basically, as many people classify it, as of two types: renewable and non-renewable. But what is so basic to all of this is the first law of thermodynamics, which says that the energy of the universe is just a fixed number. We can only convert one form of energy or nature into another form. So what we are effectively doing, we have some energy resources and we convert it into other energy forms, particularly electric power or momentum, like driving a car. We change one energy into another form. And of course we have fossil fuel first. This is the most important: coal, petroleum, natural gas. And this is non-renewable. It means, in fact, that it just decreases by the amount of consumption, like any mine that we have of metallic ore or whatever the ore is. Then we have hydropower, we have direct solar, we have wind energy that is really coming up, particularly in Europe, and we have biomass. These are renewable energy resources. And then the last two, nuclear, which is non-renewable, and finally geothermal, which is sometimes renewable and sometimes it is not. I want to stop here a little bit about this. You see, the classification of energy resources into renewable and non-renewable is not made by nature. It is made by us. And why? It is a useful classification for policy making or for understanding. When this was first done by the Gro Harlem Brundtland Committee some years ago, geothermal was not in the picture. And it so happens that this little energy resource does not fit into the classification. So what would be a more logical but not nearly as simple classification would be to look in more detail at the concept of time. Whether something is renewable or non-renewable has to do with time. So we can say something is perfectly renewable if it if this energy resource like wind renews itself at a rate equal to or greater than it is consumed by us or converted into another energy form. Then it is renewable instantly, if you like. And then something is non-renewable like fossil fuel because it forms tens of millions of years ago, more hundreds of million years ago, particularly in the case of coal. So it is like a mine. You just mine out, shall we say, chemical compounds, and you can create chemical reaction to release energy. And where does this energy, of course, come from in the very beginning? It's solar energy. And these first 5, fossil fuel and the next 4, this ultimately comes from the sun. I left out tidal energy, some little things. Gravity of the moon, which contributes to tidal energy. So this is not a complete list, but it has the most important ones. And then nuclear and geothermal, this is heat or energy form within the earth. So we have these 2 basic energy resources, solar energy in the beginning that has many forms, and 2, we have energy from within the earth. So the ultimate source of the solar energy is nuclear fusion. We fuse together hydrogen to form helium, and mass is just one form of energy. So we change the mass a little bit of the sun, and we produce heat instead, another energy form that is radiated into space. And it is the same with the heat within the earth. Ultimately, it is mass, but that is nuclear fission. As I say, we break up heavy isotopes that are radioactive into lighter elements, and we produce some energy by converting a little bit of mass into heat energy. And the isotopes that are most important for this are 3. Potassium-40, I can write this. We have uranium-238, and we have thorium-232. I don't know where the word uranium comes from. Neither do I know where the name potassium comes from. But thorium is like for quite a few elements. It is after the heathen god Thor of whatever the reason for it. And this goes way back with Nordic civilization, of course. So this is very basic to understand. These are our energy resources. But then let's look at some diagrams. Maybe you are not too fond of details like this, but I always like to play around with number. But if we take some time on this, you get an impression. So first of all, this is installed electric capacity of power plants that use nuclear energy. Gigawatts. This is a power unit. We have, of course, everybody knows a kilowatt. And 1 kilowatt is the energy, 1 kilojoules per per kilo of something. And if it is kilojoules per second, then we speak of power. How much energy we can produce in a unit of time. So gigawatt is millions of kilowatts. So this is from, you can find this on the web. This is a compilation by the International Energy Agency. And first of all,